In this problem, we're told the length of a rectangular room is 2 feet less than 3 times its width. The area of the room is 96 square feet. Find the width of the room. So with any application problem that involves a geometric figure, I normally try and sketch the figure. Notice I said sketch because these are not very accurate, so that's the closest I get to a rectangle. I know my area is 96 square feet. This is going to be the length. This is going to be the width. And we know the area of the rectangle is given by length times width. Well, we know the area is 96, so I know 96 equals L times W. But on this side of the equation, I have two variables, L and W. So I'm going to have to write either L in terms of W or W in terms of L. And that's where this first sentence comes in handy. So I'm going to translate this first sentence. It says the length of a rectangular room is. So that translates to L equals 2 feet less than 3 times the width. And directly you see this less than, be careful. This is where students mess up the most because they tend to write it in the order it's written, and they often write 2 minus 3W. That is totally wrong. If I need 2 feet less than 3 times the width, it means you start with 3 times the width, 3W, and then you're going to subtract 2 from it. So L is in fact 3W minus 2. So be very careful whenever you see these less thans. So now I'm ready to substitute this into this equation here. So I'm going to get 96 equals, instead of L, I'm going to have 3W minus 2 times W. Sorry for my bad handwriting, that was an equals. So now I'm going to simplify, so I get 96 equals, distribute the W in, so W times 3W is 3W squared, and W times negative 2 is negative 2W. So what type of equation do I have here? It's degree 2, so it's quadratic. How do we solve quadratic equations? By factoring or using the quadratic formula. And to do that, I have to have 0 on one side. But do I have 0 on the left-hand side? No. So I'm going to have to subtract 96 from both sides. So I get 0 equals 3W squared minus 2W minus 96. So now I have 0 on one side. Everything on the right-hand side is written in descending order, so I'm going to try and factor it, and if that won't work, I'll use the quadratic formula. So looking at this, is there a common factor between all three terms? They don't all have a W, and this has a 3 and this has a 2, so they have no common numerical factor. So I'm going to need a bit more room to factor, so I'm going to go to the next page. So I've written my problem here. And to factor it, we want to compare it to the standard form. So A is the coefficient of the W squared, so A is going to be 3. B is the coefficient of the W, it's negative 2. And C is the constant, it's negative 96. So I need to multiply A times C. So that's 3 times negative 96, which equals negative 288. So I need two numbers that multiply to negative 288 and add to B, which is negative 2. As there are a whole bunch of factors of negative 288, I'm going to do the table while it's on pause. As the numbers I needed multiply to a negative, the signs are opposite, and if they add to a negative, the bigger one has to be negative. So as you can see, there are a whole bunch of factors. I tried 1 and the number, 2, 3, 4, all of these numbers dividing in until finally I got to 16 times negative 18 is negative 288, and 16 plus a negative 18 is negative 2, which was the number I'm looking for. So these here, they're not my factors. They're going to help me find my factors. What I'm going to do is rewrite that middle term as 2 terms using these numbers. So I get 0 equals 3w squared plus 16w minus 18w minus 96. Sorry, it's kind of running into that. So now I have 4 terms I'm going to factor by grouping. What do the first 2 have in common? Ooh, I think the only thing is a w. So it's going to leave me with 3w plus 16. Bring down the middle sign, a negative. And what do the last 2 have in common? I think it is a 6. And 6 divides into 18 3 times, so it's going to, if I pull a negative 6 out of a negative 18w, it's going to leave 3w. And then pull a negative 6 out of a negative 96, it's going to leave plus 16. Because negative 96 divided by negative 6 is positive 16. So now, is this binomial factor the same as this one? Yes, that's my common binomial factor. So I pull my 3w plus 16 in front, and what does it leave behind? W minus 6. So now I've factored it. If you want to check it, you can FOIL it out to see if you'll end up with this problem up here. And now 2 factors multiplied together equal 0. You set both of them equal to 0. So 3w plus 16 equals 0. W minus 6 equals 0. So on the first one, subtract 16 from both sides. 3w equals negative 16. Then divide by 3. So I get w equals negative 16 thirds. And on the second one, w minus 6 equals 0. Add 6 to both sides, you get w equals 6. Now, is it possible to have a rectangle with a width being a negative number? No, so that's not a good solution. So my width is 6, and what are my units? Feet. So the width is 6 feet. And is that all they're asking me to find? Find the width of the room. Yes, so I'm done. But if they'd also wanted to find the length of the room, then you would have had to have gone back and remember the length was 3w minus 2. You'd plug the 6 in for the w, and then you'd find the length.